This is the 2024 paper of 0620, paper 2, variant 2, May, June. Let's start it. Question number 11. Aqueous copper sulfate is electrolyzed using copper electrodes. What is the half equation for the reaction at the cathode? So the cathode is negative, and obviously to the cathode negative, the positive ions, the cations, will go to the cathode. Now we have to see which cation will go to the cathode. As it is aqueous copper sulfate, so the positive ions will be copper ion. And because of aqueous, because of water, there will be hydrogen ion. So hydrogen and copper, we have to see that which one will go to the cathode when we are using copper electrodes. The copper electrodes are reactive electrodes. They are not inert. So what happens at electrodes? When we have copper electrodes and one is connected with the positive terminal, other is connected to the negative terminal. So to the negative ion, to the negative electrode, the copper leaves the 2 electrons. Each copper atom becomes copper ion after leaving 2 electrons or after giving 2 electrons. So here, from the anode, the copper ions leave the anode. They start moving towards the cathode and enter into the cathode. So the electrons, they go out of the anode, which makes electron positive, which makes the electrode anode positive. And the electrons, they enter into the cathode, which makes it negative. So the negative cathode attracts these copper ions towards itself. As copper ions are positive, so they will start moving towards cathode. So basically, in this type of electrolysis, the ions move from anode to cathode. Because copper ions in the anode, they leave the electron, they give their electrons, they donate the electrons and become copper ion. And these copper ions in the anode, they travel from anode to the cathode. Now at cathode, copper ions will go, they take up 2 electrons. Again, the copper ions, they take up 2 electrons, they gain 2 electrons back again and become copper metal. So this is the equation which occurs at cathode. So D is the correct answer. Here, the gain of electrons happens. Next question, 3 statements about activation energy are listed. Now, which statement is correct? Activation energy. Now, what is activation energy? Activation energy is the minimum energy needed for the particles to react. Or you can say to start a chemical reaction. So activation energy is the minimum amount of energy which is needed by the particles to react or to start a chemical reaction. So let's see if its statements about activation energy are correct. Colliding particles must have at least activation energy before they can react. Yes, this is correct. The particles must have this energy. Activation energy for exothermic reactions is always greater than for endothermic reactions. No, this is wrong, because the activation energy for exothermic reactions are those which release energy. So it means that the particles already have high energy. They release the energy during the reaction and then they make the products. So it means the particles already have high energy. Okay, so activation energy won't be higher, won't be greater, because already they have enough energy to turn into products. This is exothermic. Now, as for the endothermic reactions absorb energy from the surroundings. They absorb energy from the surrounding. So it means that the particles have they have very, very low energy. They absorb the energy from the surroundings and then they form the product. So the product level is always higher for endothermic reaction. So it means they do not have energy, they need to absorb energy. So it means the activation energy for the reactants will be higher. So for endothermic reactions, the activation energy is higher, which they have to reach to turn to the product. And for exothermic reactions, they do not need the activation energy. They have some activation energy which they will cross by themselves. So they don't need to absorb the energy from outside. So this is wrong. Exothermic is always greater. No, endothermic is always greater than exothermic. Activation energy is always endothermic. Yes, because it is the energy needed for the particles which the particles absorb to react. So answer is 1 and 3. Option C is correct. A student adds excess magnesium ribbon to 10 centimeter cube of 0.5 mole per decimeter cube sulfuric acid. So a student is adding excess magnesium ribbon to 10 centimeter cube. This is the volume, and 0.5 centimeter mole per decimeter cube sulfuric acid, that is the concentration of sulfuric acid. The hydrogen gas produced is collected and its total volume is measured every 10 seconds. The experiment is repeated with 5 centimeter cube, means now the volume is low, but the same concentration. Concentration is the same. The sulfuric acid added 5 centimeter cube of water using the same mass of magnesium ribbon. So it means that the sulfuric acid volume taken is less. Previously, 10 centimeter cube of sulfuric acid is taken. Now they have taken 5 centimeter cube of sulfuric acid, but they have added 5 centimeter of water in it. That means that the concentration is decreased. According to the statement, 0.5 mole is taken in the first experiment and 0.5 moles are taken in the second experiment. So one can assume that the rate will be same. That there will be same rate because the concentrations are also the same. But what they have done here, they have written that they have taken the same concentration, but if we see the volume, in first experiment, they have taken 10 centimeter cube of sulfuric acid. In the second experiment, they have taken 5 centimeter cube of sulfuric acid, only 5 centimeter means half sulfuric acid, and they have added 5 centimeter cube of water in it. So that means that the concentration of hydrochloric acid is decreased. So if the concentration is decreased, it becomes dilute. Previously, it was almost concentrated. Now it is a little bit of dilute because we have added water in it. So the reaction will be slower. The answer will be from C or D. Now, they will not end at the same point because the starting reacting particles mass is the same because they've added excess magnesium ribbon and they've taken the same mass of magnesium ribbon. The mass is the same, but the volume is changed now. Volume of sulfuric acid is changed. That's why it will decrease, means it will not end at the same point. So the answer is D. The same product will not form because the products, see, the concentration, the limiting reagent decides the total amount of the product formed. Here we have taken magnesium in excess. The one which is present in excess, it does not determine the amount of the product. It can't determine the product. The amount of the product did not depend upon the excess reactant. Amount of the product depends upon which thing is the limiting reagent, which is not in excess. Here, the sulfuric acid is not in excess, so sulfuric acid will determine the amount of the product formed. And in experiment number 2, we have taken the less concentration and the less amount of sulfuric acid. This means that the amount of the product formed will also be less. So the answer is D. It will not end at the same point. Less product will be formed this time with slower rate of reaction as we have diluted the solution with the addition of water. I hope it's clear. Next question. The equation represents the reversible reaction between ethene and steam. Delta H is negative on the product side, forward side. Which row describes the conditions that produce the greatest yield of ethanol? Ethanol means right side. What are the conditions which makes the system move towards right? Now, as we can see that the delta H is negative on the right side, so it means we have to decrease the temperature. If we decrease the temperature, then it will move towards exothermic side. So, A or B. If we see the pressure is related to the number of moles. The pressure is directly proportional to the number of moles. So if the number of moles are more, the pressure will be more. If the number of moles are less, pressure will be less. So here, in the equation, on the reactant side, we have 2 moles. On the product side, we have just 1 mole. So we have less number of moles or less pressure on the product side. So what we'll do, we will increase the pressure to make the system move towards the less pressure side. Because according to Le-Chatelier's principle, in the reversible reaction, for a reversible reaction to be in equilibrium, whatever change we do, the system will act as to oppose that change. So if we increase the pressure, system will move towards the side where the pressure is less. So we will take high pressure and low temperature. Answer is C. Question number 15. Which row identifies the pressure and the catalyst used for the conversion of sulfur dioxide to sulfur trioxide in the contact process? Now, in the contact process, we have an equation where sulfur dioxide reacts with oxygen to form sulfur trioxide. And this reaction is a reversible reaction. And to keep moving this reaction towards forward, we have to use certain conditions so that it will keep on moving forward side. The conditions we will use, the pressure will be 2 atm. We will use high pressure, 2 atm. And the catalyst used is vanadium oxide. B is the answer. We use iron catalyst in the Haber's process for the manufacture of ammonia, not for sulfuric acid. In the manufacture of ammonia, we use iron. Vanadium oxide is used in contact process to make sulfuric acid. Which equation represents a redox reaction? Now, what's a redox reaction? In a redox reaction, the RAD means reduction, which is the gain of electrons, and OX means oxidation, which is the loss of electrons. So here, which equation is gaining, which equation is losing electrons? Also, we can identify from the oxygen that which one is losing oxygen, which one is gaining oxygen, because we have another definition of reduction and oxidation. Reduction also means removal of oxygen, and oxidation also means the gain of oxygen. And here, in these reactions, in this equation, you can see that something is happening with the oxygen. The iron here does not have oxygen, but in the product, it has oxygen. So it means it has oxidized. And the water, H2, hydrogen over here has oxygen, but in the product, it does not have oxygen. So here, the loss and gain of oxygen is happening. So that means C is the correct answer. It's very clear the transfer of oxygen from water to iron is happening. This is redox. Number 17. The equation for the reaction between aluminium and copper oxide is shown. So we have aluminium plus copper oxide gives aluminium oxide plus copper. This equation is also redox equation because here the transfer of oxygen is happening. The copper oxide is giving its oxygen to aluminium. So aluminium has oxygen later on and copper oxide is reduced to copper. Which statements about this equation are correct? The oxidation number of aluminium reactant is +2. In reactant, there is only aluminium, which is in its pure form, which is element itself. So the element itself are simple metals which are not combined with any other substance. Here, their oxidation number will be 0. So the oxidation number of aluminium reactant should be 0. The oxidation number of the aluminium in the product is +6. Now let's see. The product side, we have aluminium oxide Al2O3. As for the aluminium, it is in group number 3, which makes aluminium oxidation number to be 3+. And here, in the formula also, if we do the crossover, then this 3 of oxygen will come with aluminium and aluminium will become 3+. So it is not 6+, it is 3+, or +3. Number 3, the oxidation number of copper in the reactant is +2. Let's see, we have CuO, copper oxide. Oxygen is present in group number 6, which means oxygen has total 6 electrons and it needs 2 more electrons to get completed. So oxygen always gains 2 electrons to become 2-. And if oxide ion is 2-, then it makes copper 2+. So this is correct. Copper oxidation state is 2+. The oxidation number of copper in the product is 0. Yes, because here we have only copper, which is not combined with anything like aluminium on the reactant side. So its oxidation number will be 0. So the answer, C and D options are correct. The answer is C. What is the color of thymophthalene in dilute hydrochloric acid? If we see thymophthalene, so thymophthalene color in acid, in neutral, and in alkali. What is thymophthalene? It is the indicator which indicates that a solution is acid, neutral, or alkali by changing its color. Thymophthalene is colorless in acid and neutral. It is colorless in acid and neutral. And in the alkaline solution, it's blue. So in acid, thymophthalene will be colorless. D is the correct option. Two acids P and Q with same concentration and volume are reacted separately with the same mass of magnesium ribbon. The reactions produce same total volume of hydrogen gas, but acid Q reacts much more slowly than acid P. Everything is the same. P and Q are two acids with same concentration, same volume. They are reacted separately. With same mass of magnesium, they produce same volume of the product. We're getting same product in the end. But acid Q reacts slower than acid P. Which explanation for the difference between P and Q is correct? But do you guys think acid P has higher concentration than Q, higher pH? Acid P has lower concentration of hydrogen ions. Acid Q is partially dissociated and acid P is fully dissociated. Or acid Q is proton acceptor. Now, if we see here what is happening, acid P has much higher pH. Now, pH is the measure of hydrogen ion concentration. Measure of hydrogen ion concentration. If the pH is a hydrogen ion is a measure of hydrogen ion concentration, they are saying that they have the same concentration. So it means this one is not correct. Acid P has lower concentration? No. Acid Q is a proton acceptor? Yes. No, it's no, because all the acids are proton donors. This is wrong. It means C is correct because acid Q is partially dissociated. It must be weak, and acid P is fully dissociated. It is strong. That is why Q is slower. It reacts slowly because it partially dissociates. It's a weak acid. It's of same concentration, but it's weak. P is same concentration, but it's strong. So that's why it's reacting faster. Number 20. Which process is not used in the preparation of insoluble salt? Now, insoluble salts are prepared by precipitation reaction. In precipitation reaction, we have two soluble salts. We will take two soluble salts. They react with each other and form one soluble salt and one insoluble salt. And this insoluble salt is called precipitate. Once this insoluble salt is prepared, and so we can filter it out from the soluble insoluble salt mixture. We can do filtration. After filtration, we can wash it, dry it. So filtration, after filtration, washing with distilled water, drying, everything is done in the preparation of salt, but not the crystallization. Crystallization can only occur for a soluble salt. So if we have a salt soluble in water, we can do its crystallization. We can make its crystals. So we cannot make crystals of the insoluble salt.